Okay, so we talked about unit conversions in the last video. I intentionally did not convert any temperatures because they behave a little differently. They're super weird. Okay, so this is my terrible art, sorry. They're breadsticks or worms. I'm just kidding, they're thermometers. Okay, so the thermometer was invented by Fahrenheit, which is why we measure temperatures in Fahrenheit. The problem is Fahrenheit was an idiot. So, what he did was he took a hollow tube and he filled it with mercury because it's a liquid and it expands and contracts as the temperature changes. Totally fine, doesn't really matter right now. But the problem is he didn't have any numbers to work with. He didn't know what 0 degrees was, or 100 degrees, or 50 degrees, or any of that. So what he did was he actually built this thermometer, and then he basically just stuck it to the outside of his house. And he lived in England, and every day he would go and mark it. And essentially at the end of a year, he decided that the lowest temperature was 0 and the highest temperature was 100. They are very arbitrary numbers. They have nothing to do with constants in nature or the world. They're absolutely terrible. So, that's inherently one of the problems here. So, 0 degrees Fahrenheit doesn't mean anything specific. Any of you who have lived in New York have experienced 0 degrees Fahrenheit and are aware that it's freaking cold, but it's not like a specific constant. It doesn't really matter when it gets to that temperature. And 100 degrees doesn't matter. What we care about is what temperature. Usually we use water as the constant. So we want to know what temperature water boils and what temperature water freezes. So water freezes at 32 degrees Fahrenheit. Okay? It's supposed to be a 3, sorry. And it boils at 212. These seem like completely random numbers because Fahrenheit had no plan when he designed this thing. They are random numbers because Fahrenheit was an idiot. So a guy named Celsius came along, and he basically took the same idea, and what he did was he decided this was going to be set to 0, and this was going to be set to 100. So the freezing and boiling of water, which I guess I'll label this. So this is the freezing point of water, and this is the boiling point. Basically became the measurements for where we set a 0 and 100 for Celsius. Okay, so the problem as far as unit conversions go is that basically the reason 1 inch is equal to 1 inch is equal to 2.54 centimeters, and the reason we can do a conversion like we did in the last video is because 0 inches is 0 centimeters. The reason temperature is complicated is because 0 Celsius is not the same as 0 Fahrenheit. The difference is 32, it's off by 32. And the increments are different. So every time this goes up 1, this goes up 1.8. Or every time it goes up 100, this goes up 180. So that makes things a little more complicated, which means we're going to need to use equations to actually solve for all of this stuff. Okay, so you probably saw this junior high, high school, but we're gonna do it again just to make sure you know how to do it. Okay, so it turns out that the temperature in Fahrenheit is equal to 1.8 times the degrees Celsius. You may have learned it as 9/5. 9/5 is 1.8. We're in college, I think you can handle decimals. Plus 32. So in terms of where the stupid equation came from, essentially Fahrenheit is off by 32, which is where this 32 comes from. And for every time this goes up 1, this goes up 1.8. That's where that 1.8 comes from. Okay. I will give you this equation if you need to use it on exams or quizzes. I do not need you to memorize these equations. Okay. This equation can be rearranged to solve for Celsius. So you would subtract the 32 off, and then you would divide the 1.8 over. These are the same equations, they're just this one solved for Fahrenheit, this one solved for Celsius. Okay. So there was a third worm slash breadstick slash thermometer here. And essentially some guy, the last name Kelvin, decided that these were both terrible. And he's not wrong. Kelvin, what he did was he decided that the difference between the freezing point and boiling point of water should still be 100. So this increment is still going to be 100. I'm gonna write it on this side. Okay, but he decided that negative temperatures were really, really dumb. So what he did was he set 0 really way far down there, and basically 0 Kelvin, and for some reason Kelvin doesn't get a degree sign. If you put a degree sign, I'm not gonna mark you wrong, I don't care. 0 Kelvin is absolute 0. This is the coldest temperature possible in the universe. Essentially, this is the part where like atoms stop vibrating, nothing moves, it just, nothing, there is no energy, nothing happens, okay? So the problem is, the difference between this and this is 100, but because 0 is really, really low down there, this number is 273.15 Kelvin, and this is 373.15 Kelvin. This is probably the best one of the bunch. We tend to use Celsius in lab. Honestly, we measure everything in Celsius, and if we need Kelvin, we just convert. But this is actually a really easy conversion. So Kelvin is basically degrees Celsius plus 273. Well, 273.15. Okay. So the idea is that basically you have to use a little bit of algebra to do these type of conversions. Temperatures are they're exceptional in that regard. So I'm going to do an example of a temperature conversion between Fahrenheit and Celsius because that's the more difficult ones to deal with, but literally it's just plug and chug with these equations. I do not need you to memorize these equations. Okay, I will give them to you if you have to use them in real situations. So, example. Right now, I think it's, I'm sitting in my office, but I looked at the weather earlier, I think it's like 72 degrees Fahrenheit. We want to know, oops, we want to know what is that in Celsius. Okay, so since we're solving for Celsius, we're going to use this version of things. So what we're going to do is we're going to take 72 minus 32 divided by 1.8. A little bit of math here, order of operations. We need to do the subtraction first. Sorry for that glare on there. I don't know how to fix that. Okay, 72 minus 32. We do that and we get 40, and then we divide that by 1.8. The answer comes out to 22.222222. Sig figs, we're just gonna get 22. Okay, and you'll see that I put a unit on it to indicate what I've measured. Okay, but it's literally just a matter of algebra here. If you have questions about this or if you need help, please let me know. Thank you.